Hello everyone, I am Angelica Agravante, and in this video we're going to talk about the gravitational potential energy. Basically applying the concept of gravitational potential energy in physics problems. So let's first have a recap. So energy is the ability of something to do work. Kinetic energy is a form of energy that an object possesses due to its motion. Conservation of energy states that energy can neither be created nor be destroyed. So in this situation, let's have a situation when a moving car goes uphill and it slows to a stop because of how steep it is. Where does that energy go? Or when you lift a box from the ground using your arm muscles, what happens to the energy? The answer is it turns into gravitational potential energy. So what is gravitational potential energy? It is an energy an object possesses because of its position in a gravitational field. So the higher up an object is placed, the more GPE it has. So gravitational energy, or GPE, is like height energy. So this might seem strange, but there is some logic to why it must exist. So how do we know that things have energy just because of their height? Well, let's think about the following process. First, you lift a ball off the ground until it is above your head. Next, you drop it, then it moves fast right up until it hits the ground. So in step 1, you see energy in your muscles. You use energy in your muscles to lift the ball. So you have to do work. This energy came from the food you eat, which originally came from the sun through the food you eat. Energy is said to be conserved, which means that it cannot be created or destroyed, only move from one form into another. So whatever energy we put, it has to go somewhere. So maone ang sa sun, gikan sa sun nakuan sa food, and then food na atong gi-eat, katong energy gikan adto atong gigamit para i-lift sa ball. So it really shows na energy can only be moved from one form into another. So when you lift the ball, you've used up that energy, so it has to go somewhere. We therefore conclude that it is stored inside the ball as GPE. So in step 2, you release the ball and it falls. This proves that energy really was stored inside the ball, because after releasing it, it suddenly started moving. So the ball is gaining kinetic energy, or Ki, as it falls, getting faster all the time. Gravitational potential energy is changing into kinetic energy. So in step 3, it has reached the ground but not quite hit it yet. In the instant before it hits the ground, the ball is pretty much at the height it started before you lifted it up. So it has its maximum speed and therefore its maximum Ki. This means that the Ke it has now is equal to the GPE it had before you dropped it. So once it hits the ground, this kinetic energy is absorbed by the earth. So gravitational potential energy, again, is the energy an object has because of its position in the gravitational field relative to some reference point. So this is the equation. So M is for mass of the object in kilograms, and G is 9.8 meter per second squared, that is gravity, and H is the height in meters. So let's have an example. Let's go back to our ball scenario earlier. So this time let's say you take the ball to the roof before dropping it. So if the roof is 18 meters high and the ball weighs 0.01 kilograms, how much GPE does it have before you release it? So again, this is the equation, U equals mgh. So we're just gonna times all that. So the mass is 0.01 kilograms and the gravity is 9.8 meter per second, that's squared, and then the height is 18 meters. So we multiply all that, and then we get 1.76 joules. So this number is not only the amount of gravitational potential energy it has, but also the amount of energy it took for you to lift up the ball up to the roof. So again, with the conservation of energy, diba, the energy that you used para mo adto sa roof and of the ball there transfer adto sa bola, so that GP. Next, let's have another example. So what is the gravitational potential energy of a 5 kilogram box that is 15 meters above ground? What is the gravitational potential energy of the box at a height of 30 meters above the ground? So what is the work done by gravity as the box moves from a height of 15 meters to 30 meters above the ground? So this is the formulas that we have to use for this. So let's first answer the first two, A and B. So in A, 5 kilograms times 9.8 meters and 15 meters. That is equals to 735 joules. And for B, still 5 kilograms, 9.8 meters per second squared and 30 meters. That is 1,470. So for the C, we're looking for the work done by gravity. So this is the equation. Work done is equal to gravitational force times displacement. So in this equation, you have to derive. This is the second GPE minus the first GPE. As we see here, this is the second GPE, 1,470, and the first GPE, 735 joules. So we minus it and we get 735 joules. So that is the work done. So let's have another practice problem. What is the gravitational potential energy of a 12-pound bowling ball being held 0.56 meters above the ground on Earth? So 1 kilogram is equal to 2.2 pounds. So we have to convert the pounds to kilograms. So 12 pounds times 1 kg divided over 2.2 pounds is equals to 5.45 kg. So that is the mass that we are going to use. So this is the equation and the solution. So we get 30 joules. Next is, let's have another practice problem. A larger block of stone has been raised to a height of 15 meters, has gained 6,000 joules of GPE. What mass does it have? So in this problem, we are looking for the mass. So that is this equation. M is equals to GPE over GH. Substitute and then we get 40.8 kilograms. Next problem. A really big beast of a block of stone of weight 600 kilograms gains 36,000 joules of GPE. How high has it been raised? So in this problem, we're looking for the height. So height is equals to JPE over mg. We got 6 meters. So if the problem involves large distances, we can no longer assume that the gravitational field is uniform. If we recall Newton's law of gravitation, the attractive force between two masses, m and m, decreases with separation distance r squared if g is the gravitational constant. So this is the equation if we ever get a problem that gravitational field is not uniform. But we are not going to tackle about that much because it's broad. So let's have an activity. Number 1, a massively fat cat of mass 20 kilograms is lifted 8 meters into the air. How much GPE does it gain? Next problem is a 36 kilogram girl walks to the top of stairs that are 2.0 meters high. How much gravitational potential energy does the girl gain? And that is all. Thank you for watching. These are the references where I got all the information from. And yeah, that is all.